In this video, we'll focus a little bit more on quantitative observations or measurements. Any measurement should contain a number and a unit. The number is used to describe the quantity of the measurement, and typically we use SI prefixes to simplify the numbers that we use. If we have to use very small numbers or very large numbers, we'll typically use some of the common SI prefixes. On the large side of numbers, we'll use prefixes starting from kilo, mega, giga up to tera, and on the small side we'll use prefixes starting from centi all the way down to femto. You will use these a lot, so you need to memorize them in order to make it a lot more easier to conduct calculations later on. You need to memorize the symbol for each one of these prefixes and the corresponding conversion factor. The units, on the other hand, are used to describe the property of the measurement. Each property will have its own unit. We have 7 basic properties in the SI system. We will commonly use 5 of them in this course, and maybe next semester, if you take 120, you will get introduced to ampere as well, the 6th unit. So if we go back to the definition of matter as anything that occupies space and has mass, that introduces us to the first basic properties. Mass is a measure of the quantity of matter, and the SI unit for that is kilogram. However, we typically use other units for mass in our calculations. First one is using the SI prefixes. So 1 kilogram equals 10 to the power 3 of a gram. And also in the American system, we use pounds, and the conversion factor from kilogram to pounds is 2.2 pounds per kilogram. The second basic property is volume. And volume is a measurement of the space that the substance takes, and the SI unit for that is cubic meter. However, we use SI prefixes for smaller volumes because a cubic meter is quite large volume. 1 cubic centimeter equals 1 centimeter cube, which means 1 times 10 to negative 2 of a meter. That's the translation of centi right here from the SI prefixes, and then we cube all of that. So that means 1 times 10 to negative 6 of a cubic meter. So that's the conversion factor between 1 cubic centimeter and 1 cubic meter. 1 dc meter cube is basically 1 times 10 to negative 1 of a meter cube, or 1 times 10 to negative 3 of a cubic meter. That's actually exactly equal to 1 liter, which means 1 decimeter equals 1 liter. And based on that fact, that 1 decimeter cube equals 1 liter, if we convert decimeter cube to centimeter cube, is going to equal 10 to the power 3 of a centimeter cube, which is going to equal 10 to the power 3 of a milliliter, which means 1 centimeter cube is the same thing as 1 milliliter. The next quantitative property of matter is temperature, and we have 3 important temperature scales. The first one is the Celsius scale, and this was invented based on 2 reference points: the freezing point of water as 0 and the boiling point of water as 100 degrees Celsius. Another important temperature scale is Fahrenheit, and this used a quite different reference points to define the scale. It actually used the freezing point of brine as the 0 point for the scale, and the body temperature as the almost 100 degrees Fahrenheit of the scale. And the reason why it used these two reference points for the scale was that it was actually invented by a German physician. He actually used the most convenient two reference points for him. And a third scale that was invented later was the absolute scale, or the Kelvin scale. This was invented based on the absolute 0 point, zero temperature, which is the smallest temperature possible in nature. And it has the same magnitude of the degree as the Celsius scale. This absolute temperature is equivalent to negative 273.15 degrees. So we will commonly in this course we will interconvert between these scales, and the conversion factors between the Kelvin and the Celsius are kind of quite simple, because it's just a difference of 273.15 degrees between the Celsius and the Kelvin. So you can just add them to the Celsius to get the corresponding Kelvin temperature, or subtract them to get the corresponding Celsius temperature for a Kelvin temperature. While the interconversion between Fahrenheit and Celsius is a little bit more complicated. This is a formula to convert from Celsius to Fahrenheit, and this is the formula to convert from Fahrenheit to Celsius. If we need to convert 451 degrees Fahrenheit to Kelvin, there is no direct conversion between Fahrenheit and Kelvin, so we have to take it in two steps. We will take the reading in Fahrenheit and subtract 23 degrees Fahrenheit, and then multiply it times 5 degrees Celsius for 9 degrees Fahrenheit. That should give us the number in Celsius, and we can clearly see that Fahrenheit will cancel out with Fahrenheit in this conversion, and it's gonna give us, if you use the calculator, subtract 32 from the Fahrenheit reading, and then multiply this times 5 divided by 9, and that gives you 232.777 Celsius, but you have to stop at this significant figure at the very end of the calculation. So the second step is converting that number from Celsius to Kelvin. So you will take 232.777 degrees Celsius, and then you add 273.15 to get the corresponding number in Kelvin. So we take this number, add 273.15, and that will give us 505.93 when we round it, and we stop at that decimal place for this calculation in Kelvin.